This video was produced by Virginia View, a consortium dedicated to promoting remote sensing outreach, education, and research through funding by the America View Consortium. This video was developed in partnership with the Virginia Geospatial Extension Program and GeoTED UAS. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of America View, the USGS, or other partners. The mention of trade names or commercial products does not constitute their endorsement. Remotely sensed imagery is useful for detecting changes in features on the surface of the Earth using imagery, usually from the same sensor and from two different dates. The interval between dates can be as short as a few days, for example, to detect impacts of natural disasters, a few months to assess growth in large agricultural fields, or a few to several years, such as monitoring changes in forest extent. There are two main change detection approaches: pre-classification, the topic of this chapter, and post-classification, which we discuss in coming chapters. Our example will be to evaluate landscape changes from a drought and wildland fire in southwestern Colorado on June 1, 2018. This fire, named the 416 Fire, started in the San Juan National Forest, and as of June 21, 2018, was only 35% contained and had destroyed more than 34,000 acres of forest. The extensive nature of the fire and the inability to contain it is directly related to drought conditions in Colorado. Change detection employs image differencing, which subtracts corresponding pixels and pairs of images and symbolizes the difference in color so the areas that differ in brightness can be easily identified. For this project, which band should we choose? We're interested in the effect the fire had on the landscape. Band 5 in the near infrared emphasizes biomass content, and fire will significantly lower biomass. We're also interested in the effect of the drought. Drought changes water body size, and thus shorelines. Band 5 supports the identification of shoreline, so we'll choose Band 5. To begin, download two Landsat 8 images for this region. The images are Path 35, Row 34, with dates of June 15, 2017 and June 18, 2018. Set up ArcGIS Pro by loading Band 5 from each Landsat 8 image and creating a color infrared composite of each Landsat 8 scene. Be sure to eliminate background pixels. As we learned from prior chapters, ArcGIS Pro provides several methods for creating a difference. Let's begin with a quick method. Select both layers in the Contents window by control-clicking them. Then, under the Imagery tab, select Difference from the Process drop-down menu. Go ahead and eliminate the background values for this new image. In the default grayscale symbology of this new layer, white represents an increase in a pixel's digital number, black a decrease, and gray means little or no change. But the image in some ways is hard to interpret using grayscale. So let's change the symbology to something other than grayscale, blue to red, for example. Let's zoom out to the full extent of the scene. What are the most obvious changes? Let's examine some of these using the swipe tool. First, the June 2018 image has clouds, and the June 2017 image was cloud-free. The clouds are shown as blue, one of the most extremes in the change. Second is snow cover. Snow was present in the mountains on the 2017 image. But no snow was present in the 2018 image. This change is represented in orange on the difference layer. Let's take a closer look at the image for other changes. Zoom into the area of the wildfire. Here I've set a few bookmarks for myself. Vegetation is present in the June 2017 image and missing in June 2018. The lack of vegetation on the June 2018 image shows a very high positive change in spectral values on the difference image, again showing up in orange. Let's look at one more area of change. Just to the east of the 416 wildfire are two lakes. Do you see the difference between the two Band 5 images as we swipe through them? The lakes in the June 2018 image are not as large as the earlier June 2017 image. Now let's look at the change detection image. Remember, Band 5 is often used to discern shorelines. You can see some positive change here indicated in the blue outline of the lakes. Once a change detection process has been completed, it may be helpful to apply an image enhancement technique to better discern the changes. Change your stretch method to standard deviation. You can now see the changes to the shoreline much more clearly. If you're unsure what the original features represent when looking at a change detection image, you can add a natural color or color infrared composite image to the map project. I added these images as part of the setup. Recall from prior chapters on spectral properties of Landsat bands, this band combination reveals bright red as a healthy vegetation. Now zoom to the wildfire and lakes area and swipe through to the June 18, 2018 composite image. You can see the vegetation is clearly lacking from the 416 wildfire, and the lakes are visibly smaller due to the drought. Thus far, we've completed a change detection analysis using the Imagery process difference function. Recall from prior chapters that you could have also used Imagery raster functions math minus and achieved the same result. Try that method on your own to review what you've learned. This concludes the pre-classification method for change detection. In the coming chapters, we'll cover image classification and revisit this topic.